All right, so we're going to do another video for our maximum error of change, relative error and change, and percent error and change. So it is projected that t years from now, so that's our time, t is time, and again we want units, years. The circulation of a local newspaper will be C of t, so that's our formula. C of t equals 100 t squared plus 400 t. So we always want to set these up. Plus 5,000. Estimate by which the circulation will increase during the next 6 months. So our C here is circulation. That's what it's telling us. So it's a number of people receiving newspapers, so we'll just say newspapers. That's our circulation. Okay, so it says estimate the amount by which the circulation will increase. So estimate means we are approximating. So if you remember, we have change in C over change in T. This is our approximate C over approximate T, which is, that's the approximation of it, which is our C prime of T. So we need the derivative. And if we have the derivative, it will tell us our approximate change in C and our approximate change in T. So what it's saying here is estimate the amount by which the circulation will increase. This right here is asking for DC. So that is our question. And it says during the next 6 months, that's our DT. It's giving us our DT. And 6 months, our time is in years. So if we're looking at 6 months, that would be 6 out of 12, 0.5 years. So we know our DT, and you know that this is our actual time. Lowercase t, and this is our actual C is approximately that. So we're looking for an approximation of what our change in circulation will be based on our derivative. So let's take our derivative and make a formula to find DC. So C prime of t will be our DC dt, which is 200t plus 400. So if we rewrite it like we've been doing, oops. There we have it. So now we have our 200t plus 400 dt. And so this is our approximation of our circulation. So what is our t then in this situation? So when we have these functions, they tell us what t is. T is time in years from now. And this is why very good descriptions are very important. So from right now would be 0. So now equals 0, which means our t, because it wants to know will increase during the next 6 months, our t is 0. We're starting at nothing here. Okay, so let's find our DC. Our DC is 200 times 0 plus 400. And then our DT was 0.5. So that becomes 400 times 0.5, which is 200 newspapers. That's our circulation. So our change in circulation is 200 newspapers. Now I can't just leave it that way. I have to go through the problem and make sure everything makes sense on why this is. So we took the derivative and we got dc dt is equal to 200 t plus 400. So now if we plug in 0, we get 200 times 0 plus 400 equals 400. And if we put the units on there, which is DC over DT, that's newspapers per year, right? Okay, so they're expecting 400 newspapers per year. So what would you expect it to be during the next 6 months? Well, that's half a year, so 200 newspapers. So that's all we're doing here with this is we're saying, okay, well, 400 newspapers per year, that's what that 400 represents. And we're getting half of a year, so it's 200 newspapers. So you can always just find the derivative and then just think about it as that portion that you want. And that's all you're doing here is multiplying it. You don't actually have to have a formula. Okay, so now we're at 200 newspapers. Is that good or bad? I don't know. Let's see how many they make. If they only make 100 a year, well, 200, they just doubled their circulation, right? So, well, they increased it by 200%. So what is the relative amount of increase and the percentage amount of increase for the next 6 months? So what we have to do is find out, well, what are they selling now? So if we plug in that same t, you must use the same t you used here. So we got our DC when t is 0 to be 200 newspapers. So we need to use that same t equals 0 for our c to find out what they were producing at that time that we expect that increase. See, what we're doing is you have your parabola there. We're plugging in 0, right? And we're getting our tangent. So everything is fixed on that point of 0, comma, what? And that's what we're finding here right now. So 100 times 0 squared plus 400 times 0 plus 5,000 is 5,000. So it's really 5,000. And we expect our increase to go up and over for the next 6 months by 200. So that's what we're saying. We're saying it would now be 5,200. But we're saying 500. So relative error. Sorry, I went off on a tangent there. Relative error is dy over f of x. So in this case, this would be dc over c of 0. We want to know what it is. Both of them, though, are going from 0. So our change is 200. Our actual newspapers is 5,000. So if we plug that in, it'll tell us our error. And it should make sense that they are making 5,000 newspapers, and they're expecting an increase of 200 over the next 6 months. So we want to find out what is that relative change. So 200 divided by 5,000, 0.04. And so then you're going to ask yourself, well, what does that even mean? Well, that's what we move on to the next one, which is percent change. We can say error or change. I like change in this situation, so I'm changing that one to change. And so that would be just multiply it by 100. So now we're converting our decimal into a percent. That's all it means. So if we move the decimal over 2, we end up with 4%. So now you see that they're expecting a 4% increase because it's positive. They're expecting a 4% increase in circulation over the next 6 months. That's all we did here, is find an approximate increase. See, the reason you can't do actual on this is we're talking about now. So we don't have the circulation numbers 6 months from now. What they have done is looked at their circulation over the last, maybe 3 or 4 years and created this function. And then they can use this function to see what their circulation increase would be. So by taking the derivative, finding DC, multiplying it by what 6 months represents in terms of years, they get a change in circulation of 200 newspapers. And then they can take that and divide it by 5,000 to give the actual change, the relative change. And then multiplying it by 100, they get a percent change. So it's just normal stuff that you would normally do to find out what the percentage of increase should be using derivatives. All right, thank you.